The Great Red Spot of Jupiter is one of the most iconic features in our solar system. And your grandkids will likely never see it. It's a planet-sized storm that's been raging up to 350 years, longer than the United States has been a country. Astronomers as far back as the 1660s looked up and observed it. Your grandparents saw it illustrated in school textbooks. You and your generation have seen the incredibly detailed images of the iconic red spot taken by NASA's Juno spacecraft. It seems permanent, and in as few as 20 years, it could be gone forever. But this video, it's not about Jupiter's Great Red Spot disappearing. Well, it is, but we're gonna go much, much deeper than that. Because Jupiter's spot, yeah, it isn't the only thing in our universe disappearing. Things get much, much worse. Jupiter is an awe-inspiring monster, a planet of extremes. Don't agree? Well, here are 5 mind-blowing facts about Jupiter. Number 1, Jupiter is 2.5 times the mass of all the other planets in the solar system combined. Yeah, the next biggest planet, Saturn, is only 1/3 of Jupiter's mass. 2, you can fit 1,300 of our tiny Earths inside this gas giant. Yeah, its internal volume is 1,430,000,000,000,000,000 cubic kilometers. Number 3, had it grabbed just 13 more Jupiters worth of material, it could have been a star. Yeah, it's composed mainly of hydrogen and helium, just like the sun. In an alternate reality, we'd be living in a binary star system. Some say that's the inspiration for the double sun on Tatooine on Star Wars. But not a lot of people, but almost no one actually. Me mostly. Number 4, it's got the largest ocean in the solar system, except it's not made of water. Pressure deep in Jupiter's atmosphere compresses its gases into liquid, so you get an ocean of liquid hydrogen. Oh, and its core? Yeah, also liquid hydrogen, except at those pressures, it becomes metallic and starts conducting current. And 5, Jupiter spins 28 times faster than Earth. Yeah, at its equator, it's spinning around at 43,000 kilometers per hour. That's 28,000 miles per hour. One day on Jupiter lasts 10 Earth hours. The behemoth that can hold 1,300 Earths is spinning faster than any other planet in the solar system. So, yeah, Jupiter, it's a planet of extremes. So it makes sense that it should play host to the most extreme storm humanity has ever seen. The Great Red Spot, a massive high-pressure storm that could swallow Earth. Winds exceeding 640 kilometers per hour tear around its edges. On Earth, cyclones form around columns of air that rise because of low pressure. Much rarer are anticyclones that form around columns of air being forced down by high-pressure zones. The Great Red Spot is a gigantic anticyclone, rotating counterclockwise once every 6 days. And like I said, it produces winds that howl at speeds close to 700 kilometers per hour. And put that in perspective, the fastest cyclonic wind ever recorded on Earth was Tropical Cyclone Olivia, with speeds topping out at 408 kilometers per hour. As a matter of fact, the winds in the Great Red Spot are so powerful that gases above it are hotter than anywhere else on Jupiter, heated by the energy of acoustic waves caused by the extreme turbulence of the storm. So, what's been keeping it going for all these years? Now, one factor is the Coriolis effect. On Jupiter, like on Earth, the atmosphere at the equator is traveling much faster than the atmosphere near the poles. The Coriolis effect happens when slow-moving air moves down from the poles or fast-moving air moves up from the equator. When these air masses move at different speeds through each other, they curve and together create a circular motion. Jupiter's distinct bands of atmosphere flow in opposite directions near the equator, and the Great Red Spot is like a ball trapped between two opposite currents, acting like huge conveyor belts, spinning the atmosphere between them. This position between these pervasive countercurrents, it drives the Great Red Spot's longevity. The Great Red Spot is currently 16,350 kilometers wide. That's about 1.3 times the width of Earth. Flyby measurements by NASA's Juno spacecraft have mapped it to over 350 kilometers deep. But the Great Red Spot is changing. It was once far bigger. At its peak, when scientists were observing it in the 1800s, it was estimated to be 48,280 kilometers wide, which is over 3 times the width of Earth. Even its color has changed. Over the years, it's displayed a constantly mutating mix of deep reds, fiery oranges, and even a light beige. And it's been shrinking for decades, and that's showing no signs of stopping. Recent observations show that the spot was once more elongated and is now more circular. It's a sign that it's losing structure, not just size. And this may have already happened once before. In 1665, the astronomer Cassini observed and documented what he called a permanent spot on Jupiter. He tracked it for decades, but after that, Cassini's spot on Jupiter wasn't definitively recorded again until 1831. That's 166 years later. Some modern researchers now believe that Cassini's spot was probably a completely different storm, a massive weather system like the Great Red Spot, but one that eventually collapsed and dissipated. But think about what that means. A storm many times the size of Earth, a storm that had been raging long enough for a 17th century astronomer to name it permanent, vanished silently between observations. No one noticed it was gone. No one knew another storm had taken its place. We've got an entire gap in our understanding of Jupiter's history that we'll never be able to fill. And Jupiter's not the only place that this has happened. A great dark spot was observed on Neptune in 1989, and it vanished suddenly before the next scheduled observation in 1994. Yeah, it was gone in just 5 years. And we've lost any knowledge or science that we could have derived from it. We've got no idea what we could have learned from it. You might say, what's the big deal? The Great Red Spot is just some storm on Jupiter. If it was gone today or was never there to begin with, it makes no difference to us on Earth, right? Well, not quite. Actually, not by a long shot. So, what have we learned from the Great Red Spot that a generation born after, say, 2080 might never be able to confirm for themselves? Well, we've unlocked the mystery of Jupiter's deep cloud structure and 3 different cloud layers through infrared spectroscopy, enabled by the atmospheric thinning effect at the heart of the Great Red Spot. Knowledge that's key to understanding gas giants. Studying the Great Red Spot has given scientists some of the most detailed data on how giant, long-lived vortex systems sustain themselves. And in practical terms for Earth, that research has fed into the wider field of geophysical fluid dynamics and models of the oceans. On Earth, we study the Coriolis effect and how our planet's rotation shapes our weather patterns. Well, by studying the Great Red Spot and the Coriolis effect at the extreme scale and speed of Jupiter, scientists have confirmed and refined its understanding of the phenomena. And there are real-world applications of this on Earth, potentially even saving lives. Understanding how the Great Red Spot sustains itself against surrounding turbulence gave scientists the theoretical tools to study atmospheric blocking on Earth. Oh, what's atmospheric blocking? It's when large, high-pressure systems get stuck in one place, and that lack of movement in the atmosphere can cause heat waves and cold spells. That blocking research now directly informs real decisions. When blocking is predicted weeks in advance, governments issue heat warnings, farmers adjust harvests, and food security modelers flag the risk of simultaneous crop failures across multiple continents. Without those food security warnings, one unlucky set of blocking events could cut global food production by 3% in a single year. And that's millions of tons of food absent from the global food supply. This isn't a hypothetical. There are things that we understand right now about Jupiter that future generations just won't be able to replicate. The data window is closing. And here's where this process challenges how we think about the universe. Because Jupiter's Great Red Spot isn't the only thing disappearing. Scientific evidence is being erased on a grand scale. And in most cases, we don't even know what's being lost. Because the disappearance of the Great Red Spot is just a mini version of what's happening all over the universe, to the entire universe itself. Now, we think that there's a permanence to the universe, and since our lifespan is so short and the lifespan of the universe is so incredibly long, it's not unreasonable to feel that the universe is just always going to be here. Geological time is a little closer to us than cosmic time spans, and even that manages to completely fool us. We look at mountains and rivers and oceans and think, this must have always been this way. But even the continents were, cosmically speaking, very recently all fused together in a big landmass called Pangaea. So, like the Great Red Spot, the universe as we know it is changing. It's winding down, it's expanding, it's spreading out and disappearing. And this expansion is accelerating. Galaxies are moving away from us faster than the speed of light. We already see vast swaths of empty space with absolutely nothing in them between clusters of galaxies. Think about a civilization that could evolve 2 trillion years from now. They would have an entirely different view of the universe. As they evolve to the point of having telescopes and pointing them and getting some science from the stars, they would see a few merged galaxies from their local group and nothing else. No matter how big they built their telescopes, they'd find nothing beyond their immediate neighborhood. It would be an immense nothingness with no observable phenomena. Given that there would be nothing there, they might not even try to find anything way out there. They'd have no scientific reason to believe there would be anything to find. Their cosmology would be fundamentally missing something, and there'd be no way for them to correct it. And this universal disappearing act has happened before. Certain high-energy cosmic events we now observe in distant galaxies are showing us the echo of the universe as it was billions of years ago, a universe that no longer exists. We can observe residual phenomena for clues, but we can only guess at the original events. Like the cosmic microwave background radiation that's our clearest evidence of the Big Bang is redshifting as its energy is diluted. As it gets fainter, future civilizations will have a harder time detecting it. Eventually, effectively, it'll be gone. Civilizations formed after that would have no evidence that the Big Bang ever happened. They'd have a universe-sized hole in their science. So, where does that leave us? We can't stop the Great Red Spot from fading. We can't slow the expansion of the universe. There's nothing we can do. Except for one thing. You see, we didn't evolve 2 trillion years from now. We evolved here in this narrow window of cosmic time, a time when the Earth is old enough to have formed complex chemistry and life. But the universe is young enough that evidence of its history is still visible. We evolved at just the right time to map 2 trillion galaxies and to detect the echo of the Big Bang and to pinpoint the origins of the universe. We're here to observe stars being born in nebulae that won't exist in a million years. And closer to home, we observe and study a 350-year-old storm on a planet 600 million kilometers away, at a time when we are technologically evolved enough to understand what it means. The civilization that will come after us, if and when they will appear, they'll inherit a quieter, darker, less legible universe. They'll do extraordinary science with what they have, but they won't have what we have. Your grandkids may never see the great red spot in the night sky. That's a real possibility, and that's a huge loss. Think about every civilization that has risen and fallen, leaving monuments to their achievements that we study today. Eventually, everything we do today, every bit of science we achieve and archive, will become that for future generations. We're privileged, and we need to embrace the moment. You can still see the Great Red Spot, not in a textbook, not in a historical archive, but by just looking up at the night sky. Tonight, you can point a telescope at Jupiter and watch a storm that's been churning since before modern science existed. You might spot something and write it down and help toward a new discovery. Or you can look right at a mysterious weather system that's drawn our imaginations to the planets for generations. A planet-sized anticyclone, sometimes 1 billion kilometers away, that has shown scientists how weather works on other worlds and on our own. And weather on other planets doesn't just stop at extreme storms. Some planets are so bizarre, so disturbing, that it's possible for there to be rain made of rubies or diamonds instead of water. But that's a story for another What If.